Let's try another trig identity. I got my bar in place already. Now remember, generally we start with the more complicated side and simplify it to make it look like the other side. Now in this case, I'm going to start with the left-hand side because I can use my reciprocal and quotient identities to change secant and tangent to look like sines and cosines. So that would be my first step, is I'm going to change secant of theta to 1 over cosine of theta. And I'm noting that the thing that lets me do that is the reciprocal identity. That's how I change secant to 1 over cosine. Over, now I have 1 minus the tangent of theta. I can change to sine of theta over cosine theta. And the thing that lets me change tangent into that is my quotient identities. So I've noted what identities let me change it into this. Now this is definitely the more complicated side. Once again, I'm going to give you a hint as to what to do from here, and then I want you to try to finish this on your own. What you want to try to do from here is, number 1, get common denominators and combine that numerator into a single fraction. Once this denominator is in a single fraction, then you can do keep, change, flip. Keep this numerator, change this division to multiplying, flip the fraction on the denominator, and it should start to look more like this by the time you do that. So with that hint in mind, pause the video, try this out on your own, and come back to check to see how you did. To get a common denominator on this, I'm changing the 1 to be a cosine over cosine. Same thing, but now they have a same denominator. And now that they both have cosine in the denominator, I can subtract the numerators. So the numerators become cosine minus sine all over the common denominator of cosine. Now I have a single fraction over a single fraction, so that means I can do keep, change, flip. Keep the numerator, change to multiplying, flip the denominator, and I notice, hey, look at that, my cosines cancel, and I'm left with 1 over cosine minus sine, which is what I wanted. So I ended with left side equals right hand side with my check mark. And you're done. Let's try another one. Okay, I'm going to work on this one. Put my bar in place so I don't move things from one side to the other. And I'm going to pick the more complicated side to work on first. In this case, I feel like this one is probably the more complicated side. Now, same thing. I'm going to give you a hint as to where I think you should start, and then I would like you to try this one on your own. Here's your hint. You need to start by getting common denominators so you can bring those two things together. Meaning, times this one by 1 plus sine of theta over 1 plus sine of theta, and times this one by 1 minus sine of theta over 1 minus sine of theta. So now your denominators are common. You can distribute or FOIL those together, and you can distribute the 3 into there, and you can distribute the negative 3 into that one to combine your numerators. So start with that hint, pause the video, try this out on your own, and then come back to check your work. Let's see how you did. So here is my combined numerator. I got this one times this one minus this one times this one, all over my common denominator right there for you. Now I noticed that my common denominator is difference of squares, so I FOIL that out right there. I also distributed my 3 and my negative 3 in to get that. I noticed that my 3's canceled and my sines canceled. So I have 3 sine of theta plus 3 sine of theta gave me 6 sine thetas. And on the bottom I have 1 minus sine squared, which I noted is a Pythagorean identity. So I can change that into cosine squared. Now this is where you may have gotten stuck. This part is a little bit tricky. I split this up, meaning I know that cosine squared is cosine times itself. So I can split up those fractions like this. And if you notice, it is the same thing. This is 6 over 1. So if I multiplied all the numerators together, that gives me my 6 sine theta. And if I multiplied all my denominators together, I'd get cosine times cosine. That is my cosine squared. That's the trickiest part of this problem, is splitting up these fractions into these individual ones. Now, why might I do that, you might ask? Because I know sine over cosine turns into tangent because of the quotient identity, and 1 over cosine turns into secant with the reciprocal identity. Now, last step I got to do is move these things around. Because it's multiplying, I'm allowed to do that, so that I get the right-hand side equals the left-hand side. Check. I'm done. So, we have one more trig identity to go. Hopefully, these are starting to get a little easier, but remember, it only gets easier with practice. That's the best way to get better at trig identities. So, take this last problem. We put our bar in place so we don't move things from one side to the other. I need to start with the more complicated side. In this case, there isn't really a more complicated side. They're both pretty equal. They're both pretty equal here. However, I like to typically start with the left-hand side and make it equal the right-hand side. Don't know why, it's just how I am. So I'm going to start with the left-hand side over here. And I am going to try to use a Pythagorean identity. Now, to use a Pythagorean identity, that usually means I need difference of squares. So if I multiply this difference of squares out, that's going to give me a Pythagorean identity I can simplify with. But if I multiply the bottom by that difference of squares, 1 plus cosine, I also need to multiply the top to keep it balanced. So this is your hint on where to start this. Start by distributing that and foiling or distributing this. See what you get, and then see if you can use your identities from there to make it to simplify to this. Pause the video for this very last problem, try it out on your own, and then we'll be done. Let's check your work. So I started by distributing the sign. That gave me this. Then I foiled or distributed the bottom, the difference of squares, and that gave me this, and my cosines went away. So I ended up with 1 minus cosine squared in the bottom, which I then used a Pythagorean identity to change that to sine squared. Then I noticed that the top has a sign in common. So if I pull that sign out of what they have in common, then I can split my sine squared up as sine times sine, and I can cancel a sign on top and bottom. And when I do that, I am left with this, which matches my right-hand side. That's what I wanted. So that is a little bit on trig identities. You have a lot more practicing to do, and I promise with more practice, the easier it will come. We are officially done with lesson 1.5. You can now get started on your homework.